The direct relationship between rising heat densities in server equipment and the increased risk of fire is a major challenge for telecommunications facilities and data centres globally. The cost of downtime in a telecommunications facility or data centre can exceed $2 million per hour, as even a small amount of smoke within or near a cabinet can cause expensive IT equipment to become damaged due to corrosion. It's time to take a closer look at your smoke detection system. Two types of smoke detectors compliant with international standards are put to the test. The following tests were conducted in a facility designed to emulate a telecom or data centre. Fire engineers, consultants, insurers, contractors, installers and end users were present. The tests will compare the time it takes for the two competing technologies to detect smoke and will show how factors such as air change rates and air dilution from air conditioning systems affect the time it takes for the fire to be detected. The first detector is an extralis Vesda air sampling or aspirating smoke detector. This is an active detector using a network of pipes to continually draw air from a protected area. The second detector is a conventional point or spot detector that uses passive technology. The detectors are installed in 4 commonly protected areas as prescribed by codes and fire risk assessors. The ceiling for general area detection, across the air conditioning return air grill, induct and cabinet detections are used to detect smoke that originates from smouldering electrical components. There are 3 different fire detection designs to suit 3 different cabinet styles. The point or spot detectors were mounted next to each Vesda sampling hole, with the fire being lit at the furthest point along the Vesda sampling pipe. Unlike the point detector, the Vesda detector has to transport the smoke through the sampling pipe and back to the detector before it can analyse the smoke and signal an alarm. To ensure the detectors were 100% operational, both were certified as operational prior to testing. The test methods were run in accordance with the British Standard 6266 hotwire test, with fire scenarios consistent in nature to those that would be found in a server room. The first test method produces an initially slow-growth smouldering fire, similar to overheated PVC-coated electrical wires. The second test method produces a short period of smouldering smoke, similar to an overheating resistor on a circuit board. The third test method produces a large quantity of smoke and is used to imitate a fast-growth fire. Both detectors were programmed to trigger the strobe sounder at the fire alarm level. Test 1 simulates an overheated PVC wire fire, which is lit on the floor at the furthest point of the room from the detectors. The Vesda Laser Plus detector on the ceiling goes into alert at 99 seconds. At 129 seconds, the Vesda Laser Compact detector across the return air grill goes into alert. The Vesda Laser Focus detector sampling in the cabinets goes into alarm at 137 seconds. At 145 seconds, the Vesda Laser Compact detector in the duct goes into alert. After 180 seconds, the point detector has still not detected the smoke. In Test 2, a PVC cable fire is lit on the floor next to the return air grill. The smoke is drawn up into the return air duct but does not reach the ceiling-mounted detectors. The Vesda Laser Compact sampling in the duct goes into alert at 17 seconds. After 180 seconds, the point detector located on the return air grill has still not detected the smoke. Test 3 simulates an electrical component fire originating within a server cabinet that is ventilated from bottom to top. The Vesda sampling pipe is positioned across the top of the cabinet to detect the smoke as it is carried upwards with air currents. point detectors are not positioned near the cabinets due to the negative electromagnetic effects on the server equipment. At 50 seconds, the Vesda laser focus detector across the top of the cabinet triggers the alert level. The Vesda laser compact detector, located across the return air grill, goes into alert at 68 seconds. At 71 seconds, the Vesda laser compact detector in the duct goes into alert level. After 130 seconds, the point detectors have still not detected smoke. In this test, the server cabinet is fully sealed and the sampling pipe is located within the top of the cabinet. At 28 seconds, the Vesda laser focus, sampling from within the cabinet, goes into alert. The Vesda sampling pipe is located at the back of the server cabinet to catch the smoke as it is carried with air currents. At 24 seconds, the Vesda laser focus detector goes into alert. After 130 seconds, none of the other detectors had detected the smoke. This test demonstrates how much smoke is required to make the conventional point detector go into alarm. At 31 seconds, the Vesda laser focus cabinet detector activates fire alarm level. At 35 seconds, the Vesda laser compact detector across the return air grill goes into fire 1 alarm. At 36 seconds, the Vesda detector in the duct triggers fire 1 alarm. After 70 seconds, the Vesda detector on the ceiling goes into fire 1 alarm. After 4 minutes and 15 seconds, the point detector on the return air grill goes into fire alarm, which does not meet the test requirement to trigger a pre-alarm within 180 seconds. The Vesda detectors are all at fire 2 alarm at this stage. In each test, the Vesda system detected the presence of smoke and raised the alarm while the fire was still in its very early stages. Vesda, coupled with intelligent response options such as automatic shutdown of air handling units or automatic alerts via SMS, can prevent business downtime and damage to expensive equipment. In zero-tolerance environments where business continuity is imperative, Xtralis Vesda is the reliable choice for the very early detection of fire.
The performance of Vesda, as expected, was exceptional. It's able to detect the fire at a very early stage, which as a designer or as a consultant, I need to know just exactly where its parameters are, where it best works. In a good, clean environment, it can actually smell the smoke really early on, and sometimes that's what we need to do.